if you need to know or want to learn how to sketch any graph quickly, then you're in the right place. If you want to take a more comprehensive approach to this, then I recommend you watch my video that I've linked in the description. So we are sketching f of x equal to x over the square root of x minus 1. So it's a four-step process. We find the domain. We then look at intercepts and asymptotes, and then intervals upon which our graph is increasing, decreasing, positive, negative, and concave up and concave down. All right, so for the domain of this function, we are looking at the denominator, and the denominator cannot equal to 0 because then the function's undefined. So that's where this restriction comes. So therefore, if we solve that, we eventually get x cannot equal to 1. Now, because we also have a square root in our function, x always has to be greater than or equal to 0. So taking the intersection of these two sets, we get this as our solution. So we figured out the domain. All right, now we move on to intercepts. So for our intercepts, we let f of x or y equal to 0. And if we do that, we'll find out that our x is equal to 0 because our numerator is equal to 0. All right, and now just to check and see that we don't have more than one intercept of the y-axis because we've found x equal to 0, we let x equal to 0 again to see if there is another one. And there isn't actually another one. All right, so now we move on to asymptotes. So we get our asymptotes from our denominator. Our denominator where it makes our function undefined. So where our denominator equals 0, which solves to be x equals to 1, and that's a vertical asymptote. Now, you could also solve for horizontal and oblique asymptotes, but I'm not going to go through that in this video. If you want to know more about that, I recommend you watch my other video. Okay, so on to intervals. So let's do the derivative of f. So I've done the derivative of f over here, and it came out to be this function. All right. Now, we needed to know that because we're using the derivative to find where our function is increasing or decreasing. So if we want to find out where it's increasing or decreasing, we have to find out the stationary point or where it's equal to 0, because this is a defining point where a graph turns. So it defines where it can be increasing and decreasing. So where f prime of x is equal to 0 is where the numerator is equal to 0. So that's why I've said 1 over 2 times by the square root of x minus 1 equals to 0. And that solves to be x equals to 4. So we have a stationary point at x equals to 4. Okay, now we plot on our sine table these critical values. 0, because that's our intercepts with the axes, which was at the origin. 1, because that's our vertical asymptote. And 4, because that's our stationary point. So plugging in values at 0, we obviously know that f of x is equal to 0. And then plugging in a value between 0 and 1, our f of x was negative, and our f prime of x was also negative, which means that it was decreasing and it was below the x-axis. Now between 1 and 4, we substituted in a number, and we found that our f of x was positive, so above the x-axis, but it was decreasing. And then obviously at f of x equal to 4, that was positive, but it had a stationary point, which is why f prime of x equals 0. And then beyond 4, it has a positive gradient and it's above the x-axis, hence the two pluses over here. So with this information, we can go ahead now and sketch the graph. So obviously to the left side of the y-axis or x equals to 0 line, we don't have, it's not part of our domain, so we don't sketch that because there's no function that exists there. Okay, then we look between 0 and 1, and we see that our graph was decreasing and it was negative. We had an asymptoted one and it was equal to 0 at the origin. So our graph exists there. We had an asymptote over here at x equals to 1, and it was decreasing, which means it had a negative gradient, and it was negative, meaning below the x-axis. And now, the thing to note about asymptotes is if this graph was doing this, it was wanting to be negative and decreasing, and as it got closer and closer to the asymptote, it couldn't cross it, so it had to bend away, which is why we get that general shape there. So sometimes there's no need to do a concavity test with the second derivative, and most of the time you don't need to do that, but there are cases where you do need to do that, so make sure you're aware of that and you do know how to do it if you do need to do it. Okay, so let's move on to this section of the graph between 1 and 4. We look at our sine table and we notice that our function is positive and decreasing, and then it comes to a stationary point at 4. So it makes sense then that our function has this stationary point here at 4, and it's positive here, and it has a negative gradient. Okay, and now notice again with this asymptote, if it's decreasing, which means if we were to go in that direction, we'll be going up the slope and up the slope and up the slope, and as we get closer and closer to this asymptote, we start curving away, which is why it is concave up. You also could have got that from the second derivative test, but as I've said, it's not necessarily necessary. Okay, so now we go beyond 4, and our graph is positive and increasing, which is what we can see here, obviously from the stationary point at 4. So this is the final solution, and this is the graph sketched by itself. If you did try this for yourself, well done. And also, if you managed to do it, that's an even bigger accomplishment. And I hope you found this video helpful, and if you learned something from it, please don't forget to leave it a like and subscribe to my channel. Thank you for watching.